Welcome. Let's look at the rational function of f of x and let's try to identify a special asymptote. When I look at the degree of this rational, I notice that the degree of the numerator, it is of degree of 2, and on the denominator, the degree is 1. And when we have this specific scenario where the degree of the numerator it's exactly 1 higher than the degree of the denominator, we're always going to encounter what we call a slant asymptote. It is going to be an asymptote that is not horizontal or vertical, but diagonal. And when I graph this function, I can see this happening because notice that there is a diagonal line that my graph is following as it's moving to negative infinity and positive infinity. Well, how can I find the function for this slant asymptote? Well, there's a process that we have to discuss. Well, how about we try to rewrite this rational function? Because we are dividing two expressions, let's perform long division. The denominator, let's write it outside. And the numerator, let's write it inside. Remember that we want to match variables. So x, what do I have to multiply so that I end up with x squared? Well, that's the expression of x. Now that we know which variable we need, let's perform the multiplication. X times x, that's x squared. So let me write it here on the bottom. And don't forget to multiply the second term. So we'll have negative 3x. But before we combine, we switch the sign. So what we had as positive is negative, and what we have as negative is positive. Now let's combine. X minus x squared, that's gone. 3x plus 3x, that's 6x. And now let's bring down what we have not combined, which is negative 6. And now let's repeat the process. On the outside, my first term is x. On the inside, my first term is 6x. X, what do we have to multiply so that we end up with 6x? Well, that's just the value of 6. So let's write that out. And now let's perform that multiplication. X and 6, that's 6x. Let's write it on the inside. Negative 3 and 6, that's negative 18. But before we combine, let's switch the sign. Negative 6 and positive 18. Now let's combine. The 6x are going to cancel out. And when we combine negative 6 and 18, we're going to get 12. But this is as far as we can go because this is our remainder. So what we have shown with this division is that the initial polynomial, it can be written out as x plus 6 plus 12 divided by x minus 3. So let me erase my work to make an observation. But now I'm going to consider the new form of my initial problem. X plus 6 plus 12 divided by x minus 3. But when I take a look at the behavior of this slant asymptote, notice that one direction is the behavior when we are going towards positive infinity. So now let's see what happens when we consider this direction. But I'm going to consider my new form of my rational function. Well, notice what's happening on this expression where we have a remainder. When this variable of x it's increasing without a bound, the expression it is getting very small. It's so small that we can consider it as if it was a value of 0. So I am going to treat it as if it was 0. And this expression that is left as x plus 6, well, that's going to be the function of this slant asymptote. So now we have identified the function that we were looking for, the function of this slant asymptote. And we will always obtain this behavior when the degree of the numerator it's exactly 1 degree higher than the denominator. Hello. If you would like to continue learning about mathematics, you can check out the videos on the left.